In this lesson, we're going to look at precipitation reactions that result from the mixture of two ionic compounds dissolved in water. We've talked about the solubility of ionic compounds, and we've talked about how ionic compounds are strong electrolytes when dissolved in water. Now we need to see what happens when we mix those two things and what can form from that reaction. Precipitation reactions are the most common type of reaction that result from the mixture of two aqueous solutions that are formed from ionic compounds. Precipitation reaction is one that results in the formation of a precipitate, and a precipitate is just the insoluble solid that separates from the solution. In the same way that rain or snow is called precipitation, you can think about them forming and coming out of the gas phase that is the air. We see the same thing with these solids forming from the aqueous solution and coming out of solution. And we use our solubility rules to predict the precipitate that will form. If we look at the image here, we see that we have lead iodide forming. I had the reaction of lead nitrate plus potassium iodide, which are both soluble compounds. I looked at the potential products, and we see that lead iodide and potassium nitrate are our products, and lead iodide is insoluble in water, so it's listed as a solid in the reaction, and therefore is the precipitate that forms. The KNO3 is aqueous, meaning it's soluble in water, therefore it will remain in the solution as ions. When we're looking at two aqueous solutions being combined, we can predict the potential products and then identify what is soluble and what is insoluble. Let's look at an example here with lead nitrate and potassium iodide. Note that we must have a cation plus an anion. We cannot pair two cations or two anions because they have like charges and will repel each other. Basically, we're going to swap ions. In our original reactants, we see that lead is paired with the nitrate ion, and potassium is paired with iodide. Therefore, we're going to put lead, which is a cation. We know it's a cation because it's a metal, and if we're looking at the formula, it's written first. We're going to pair that with iodide to form the PbI2, and we're going to pair the potassium ion with the nitrate ion to form KNO3. Notice that we have to redetermine the formulas on the product side. Although there's only one lead and one iodide in our reactants, we see that one of our products contains one lead and two iodides because lead has a 2+ charge, iodide has a -1 charge, and when we crisscross down, we get PbI2. Based on our solubility rules, we know that this is an insoluble compound, so it forms a solid when those ions are combined. For KNO3, we have our K, which has a +1 charge, our nitrate, which has a -1 charge, and we crisscross those down to get KNO3. We put a coefficient of 2 in front of that in order to balance the reaction, but the compounds that are formed on the products have to be redetermined every time we're looking at a reaction. What are the two possible products of this reaction? We see that the ammonium is paired with the sulfide initially, therefore the only other thing it could be paired with is the nitrate. The copper starts with the nitrate. The only other option to pair it with is the sulfide because we must have a cation and an anion. So our two potential products are ammonium nitrate and copper sulfide. Notice that for the products, we had to look at the charges on each ion to determine the appropriate subscripts for the formula of the potential products. Which compound is insoluble in water? NH4NO3 contains two ions, which have no exceptions in the solubility rules, therefore it is a soluble compound. Ammonium copper doesn't form because that's two cations coming together. Copper sulfide is insoluble in water. Sulfides are generally insoluble compounds, and copper is not one of the exceptions. Sulfide and nitrate do not form a compound because they are both anions and will not bond together. Therefore, C is the insoluble compound. What will the precipitate be for this reaction? Since copper sulfide is the insoluble compound, that will be the precipitate that forms. The ammonium and the nitrate will still be in the solution, but they will be present as ions dissolved in water or aqueous ions.